Hawkins, Indiana, 1983. It is the ultimate fantasy. A secret government lab, a gate to another world, and a dark, twisted reflection of our own reality, just waiting on the other side. The Upside Down is iconic because it feels so close. It's our houses, our streets, and our pools, but just colder and filled with floating spores. The show tells us that if we just find the right psychic kid or build a strong enough Russian magnet, we can punch a hole in the wall and walk right in. It looks terrifying. It looks dangerous. But it is a lie. Netflix wants you to believe the scariest thing about a parallel universe is a flower-faced monster that eats your cat. Netflix is wrong, because real physics, specifically string theory and the many worlds interpretation, suggests that parallel dimensions are real. They are mathematically certain, but they aren't scary because they are full of monsters. They are scary because they are forbidden. The math says you can't walk there. And if you try, if you actually manage to step through a hole in reality like 11, you wouldn't find a spooky version of your hometown. You would find a universe that hates your biology. A universe that would dissolve your atoms before you even had time to scream. We are going to look at the real science of the multiverse. And I promise you, by the end of this video, you will wish the Demogorgon was real. To explain the Upside Down, the show uses the famous Flea and the acrobat analogy. It's a great scene. Mr. Clark, the teacher we all wish we had, explains that an acrobat on a tightrope can only move forward or backward. But a flea can crawl around the rope. It can access a dimension the acrobat can't see. The show implies that we are the acrobat, and if we just become the flea, if we generate enough energy, we can find a door on the side of the rope. Surprisingly, the physics here isn't total nonsense. It's based on the Kaluza-Klein theory from the 1920s, and modern string theory takes it even further, suggesting the universe has 10 or maybe even 11 dimensions. So, Mr. Clark is right? We just need to learn how to walk sideways? Wrong. He forgot one tiny, fatal detail. Scale. In the show, the flea is small, but it's still visible. In reality, these extra dimensions are compactified. That is a fancy physics word for curled up smaller than you can possibly imagine. They exist at the Planck scale. That is 10 to the negative 35 meters. Let me put that into perspective for you, because the human brain is bad at small numbers. If an atom were the size of the entire Milky Way galaxy, the Planck length, the size of this dimension, would be the size of a single tree on Earth. It is the pixel size of the universe. So, you can't just walk into these dimensions. You are too fat. Your atoms are too fat. Even your electrons are too fat. To enter a Kaluza-Klein dimension, you wouldn't need a gate. You would need to compress your entire biological mass into a space smaller than a proton. If 11 opened a portal to a real extra dimension, she wouldn't see a creepy version of the school gym. She would see a singularity. And if you tried to step through it, you wouldn't enter the Upside Down. You would undergo spaghettification. Your body would be crushed into a stream of subatomic soup instantly. The acrobat doesn't become the flea. The acrobat becomes a smear of cork paste. But let's say size doesn't matter. Let's say you want to force the door open anyway. In Stranger Things, opening a portal takes a toll. 11 gets tired. She screams. And most famously, she gets a little nosebleed. It's very dramatic. But in terms of physics, that is the biggest discount in history. Opening a wormhole, which is essentially what a gate is, requires bending the fabric of space-time until it rips. Do you know how much energy that takes? It takes negative mass, and it takes an amount of energy roughly equal to the mass of Jupiter converted entirely into pure light. If 11 actually channeled enough energy to tear space-time, she wouldn't get a nosebleed. She would vaporize the state of Indiana. Actually, she would probably crack the Earth's crust. The heat generated from that kind of energy transfer would be hotter than the surface of the sun. Hopper wouldn't be standing next to her looking concerned. Hopper would be plasma. The show treats interdimensional travel like it costs about as much energy as running a microwave. In reality, it costs more energy than the human race has generated in 10,000 years combined. So, the next time you see her wipe a drop of blood away, just remember that she should technically be a thermonuclear warhead. But let's assume you survive the size problem, and you survive the heat problem. You still have the timeline problem. The show relies on the idea that the Upside Down is a shadow of our world. It's a timeline that went wrong. This relies on the many worlds interpretation of quantum mechanics. This theory says that every time a quantum event happens, the universe splits. In one timeline, the cat is alive. In another, The cat is dead. In one timeline, Will Byers is playing D&D. In another, he is being haunted by a Demogorgon. Sounds promising, right? It sounds like the Upside Down is just a dead cat timeline away. But there is a catch. It's called decoherence. Think of reality like a glass of milk. When the universe branches, it's like spilling that milk. Once it spills, it spreads out. It interacts with the floor, the air, and the cat. To put the milk back in the glass, you wouldn't just need a portal. You would need to reverse time for every single molecule of milk, air, and floor dirt. This is what physics calls chaos. And chaos is the bouncer that kicks you out of the club. Once a timeline split, it is mathematically sealed off. The door isn't just locked. The door doesn't exist anymore. You are trapped in your own branch of reality. Trying to jump to another timeline isn't like walking into the next room. It is like trying to unshatter a glass by screaming at it. 11 isn't psychic. She's just ignoring the laws of physics. And trust me, physics always wins. One of the coolest moments in the show is the compass scene. Dustin figures out that the gate creates a massive electromagnetic field. It disrupts the Earth's magnetic field. So, all the compasses in Hawkins point to the lab instead of north. It's clever writing. It makes science look like a treasure map. But let's bring real physics back into the room to ruin the fun. If a tear in space-time was generating a magnetic field strong enough to spin a compass from miles away, Dustin wouldn't be looking at his compass. He would be dead. Let's talk about MRIs. An MRI machine has a magnetic field of about 1.5 to 3 Tesla. It is strong enough to rip a piercing out of your ear or suck a chair across the room. But the field Dustin is tracking? To overpower the Earth's magnetic core from 5 miles away, we are talking about a field thousands of times stronger than an MRI. We are talking about magnetar levels of power. At that strength, magnetism isn't just about moving metal. It messes with the chemistry of your body. The iron in your blood isn't magnetic like a paperclip, so you wouldn't explode like Magneto. But the electrical signals in your nerves? They rely on ions moving around. A magnetic field that strong would stop your heart instantly. It would scramble your brain signals like an egg. So, if you ever look at a compass and it starts spinning wildly because of a nearby portal, don't follow it. Just lie down, because your nervous system is about to shut down permanently. But let's play devil's advocate again. Let's say you survive the spaghettification, you survive the heat, and you survive the magnetic heart attack. You finally step through the gate. In Stranger Things, the danger of the Upside Down is the atmosphere. The air is toxic. It's filled with spores. You need a hazmat suit to breathe. That is adorable. Real parallel universes don't just have bad air, they have bad math. Physicists call this the fine-tuned universe problem. The laws of physics in our world are set exactly right for life to exist. The mass of an electron, the strength of gravity, the speed of light. These are specific numbers. If you go to a parallel universe, those dials might be turned just 1% to the left, and 1% is enough to kill you in ways horror movies haven't even invented yet. Let's say you step into a universe where gravity is just 2% stronger. You wouldn't just feel heavy. Your heart is a pump designed for Earth gravity. In this new world, your heart isn't strong enough to push blood up to your brain. You would pass out in seconds. Then, your heart would try to compensate, beat faster, and eventually explode inside your chest. But that is the good ending. What if electromagnetism is 1% weaker? Electromagnetism is the glue that holds your atoms together. It keeps your electrons orbiting your nucleus. If you stepped into a universe where that glue is weak, your chemical bonds would just stop working. You wouldn't die. You would unhappen. Your proteins would unfold. Your DNA would snap. Your skin would liquefy. You would instantly dissolve into a soup of biological sludge. The Demogorgon is scary because it has teeth. Real physics is scary because it doesn't need teeth. It just deletes you. But the scariest part of the multiverse isn't the sludge. It is the ghosting. In Stranger Things, the Upside Down is lonely, but it has Wi-Fi. Joyce can talk to Will through the Christmas lights. Dustin can hear his friends on the walkie-talkie. You are never truly alone. Real physics is a lot colder. Parallel universes have a strict rule: no contact. Once a timeline splits, the other you isn't your brother anymore. They are a total stranger. You can't call them. You can't text them. You certainly can't use holiday decorations to ask if they are okay. Every choice you make creates a new world, and you are instantly banned from it. It is the ultimate solitary confinement. And if a door did open, If the scientists at Hawkins' lab actually punched a hole in reality, it wouldn't look like a glowing red scar. It would look like the end of everything. Physicists call this vacuum decay. I call it the big delete. Imagine a bubble of new physics appearing in the lab. It would not let a Demogorgon through. It would expand at the speed of light, rewriting the laws of chemistry as it goes. It wouldn't just eat Barb. It would delete the entire galaxy before your brain could even process the flash. The upside down is scary because it lingers. Real physics is scary because it doesn't leave room for a sequel. So, is the upside down real? Logic says no. Physics says absolutely not. The math screams at us that dimensions are either too small to enter, too hot to touch, or too unstable to survive. But Stranger Things gets one thing right: the human element. We don't watch the show because we care about magnetic fields or particle physics. We watch it because we are desperate for connection in the real universe. If you scream into the void, nothing screams back. It is quiet. It is indifferent. It doesn't care if you live or die. That's why we invent places like the Upside Down. We want the monsters to be real. We want the Mind Flayer to be real. Because if there is a monster hunting you, at least you aren't being ignored. At least the universe notices you. So, enjoy the show. Enjoy the fantasy. But be grateful that the screen is the only barrier between you and the truth. Because in the real multiverse, no one is coming to save you, and no one can hear you scream.